Magnetism, question 5. The rectangle of wire shown moves towards a magnetic field. Calculate the EMF induced in the wire when side AB, this side here, has entered the field, but CD, here, has not. Well, we're given the dimensions of the rectangle, and it is approaching the magnetic field at 3 centimeters per second, and the magnetic field has a flux density of 50 millitesla. For this we can use the EMF is equal to minus delta phi by delta t, where phi is the magnetic flux. The magnetic flux in this case is given by the magnetic flux density B multiplied by the area A multiplied by the number of turns n being 1 in this case. So we can write that EMF is equal to minus delta BAN by delta t. But the minus sign just gives the direction of the EMF according to Lenz's law, so I'm going to ignore it from now on and just find the magnitude. Only area changes, so we can simplify this to EMF is equal to Bn delta A by delta t. And so the EMF is equal to BNLV, as the change in area, the area swept out by AB, is given by the length of the wire multiplied by the distance it moves in a particular time, its speed. Putting in the values, we have B of 50 millitesla, number of turns is 1, the length is 0.05 meters, 5 centimeters, this length here, and the speed is 0.03 meters per second, which is 3 centimeters per second. This gives an EMF of 7.5 times 10 to the minus 5 volts. Next we're asked in what direction will the current flow. Well, by Lenz's law, any current flow will act to maintain the current situation, and the rectangle has gone from having no field passing through it to a field going through it going into the screen. Therefore the current will attempt to produce a field coming out of the screen. If you curl the fingers of your right hand so they would come through the rectangle out towards you, as you grip wire AB here, your thumb points from B to A, showing that the current flow will be in this direction, anti-clockwise. Next we're asked what EMF will be produced when the whole wire is within the field. Well, now there will be zero EMF as there is no change occurring. Now we're asked what EMF will be produced when AB has left the field and CD is still within the field. Well, now we have the same situation but in reverse, so again we'll have 7.5 times 10 to the minus 5 volts, same as we had here. And finally, what direction will the current be in now? Well, now the rectangle is going from having a field passing through it into the screen to no field, and so it will attempt to continue the field going into the screen with a current flow in the clockwise direction.